Hello, today we want to continue with the Cauchy-Schwarz masterclass and we want to solve an exercise together. So given n non-negative and real numbers, p1 to pn, satisfying the following equality, which is that they all sum up to 1. And also, suppose that we are given two n non-negative real numbers, namely a1 to an and b1 to bn, satisfying the following inequality, which is that aj times bj are multiplied with each other are bigger or equal to 1 for all j, then the following inequality holds. Okay, why is this true? Let's prove this. So we want to use the fact that aj times bj, bigger or equal to 1, implies that the square root of aj and bj is also bigger than or equal to 1. Because when we take the square root, we only consider the positive numbers in our case. In fact, for all of the Cauchy-Schwarz masterclass. Therefore, we have, for the following summation from 1 to n, pj times square root of aj times bj is bigger or equal, since this here individually is bigger or equal to 1, then the summation overall is bigger or equal to the summation of pj's. Well, we have implicitly a1 here times 1. Okay, that's just the summation of all these pj's, which is just 1. That was our condition. That's the first point that we use. So let's mark this with red dot. We have another point, which is that we're going to use the Cauchy-Schwarz inequality, which, to reiterate it again, is the summation of pj times aj from 1 to n times the summation from pj and bj from 1 to n are both bigger or equal to the summation of pj times the square root aj bj from 1 to n to the power of 2. Okay, so now we have two inequalities and we want to combine them into one. We know from the first point, so let's number this with 1, and this here is then 2. This here is bigger or equal to 1 because of inequality that we derived from point 1. Now we said that here, the left-hand side, summation of pj times the square root of aj times bj is bigger or equal to 1. That was what we derived. So ultimately, we have now that this is bigger or equal to 1 squared. Well, then that's just 1. So we have concluded that the multiplication of these two summations are in fact bigger or equal to 1.